Okay, so let us get to the next sections. Okay, so we will talk about 5.4 first. Okay, then we go back to section 5.3. Okay, now 5.4 basically we talk about the fundamental theorems of calculus. Okay, we call it just FTC. Okay, now let us look at what is the concept about these theorems right here. Okay, now why not? If you remember something that we learned in section 5.2, that we talk about that if we want to take the integral between 1 and 4th of the integrand 1 plus 2t, the t here, is actually mean that we are looking for the area, okay, between the functions and the x-axis, right? So this is what we are looking for. And then my lower limit is 1 and my upper limit is 4. Okay, so this is exactly what we are looking for. We are looking for the area. Okay, so then this is actually what does this mean, right? Okay, so then of course, if this is the case, then we know that if my input is 1, then in this case, 1 plus 2 is 3. So then we know that this height right here is 3. And of course, when input is 4, 4 times 2 plus 1 is 9. Okay, and then now the length here is actually 3. So we have a trapezoid. So therefore, the area to this one right here is actually 3 plus 9 times 3 all over 2. Then it will be 12 times 3 over 2. Then we know that in this case, it is 18 then. Okay, so then in this case, it actually is telling me that if the integral between 1 and 4th of 1 minus 2t or 1 plus 2t dt is equal to 18 then, okay? Again, because this is kind of like the area of this region right here, right? Okay, so why not? What if I have my lower limit is still 1. However, my upper limit is x, meaning what? It's just any values on the t-axis. And then right now, in this case, basically what we're looking for is, again, we look at this area right here. But right now, instead of we have a fixed number on this side, we have a variable, right? Depend on the input x then, okay? So therefore, again, to this one, how do we actually work out this? So now, again, remember this area right here, it will be 1 to x of 1 plus 2t dt, okay? Again, is the area depend on the x value then. Okay, then now, if this x is the input, then of course this height right here, it will be 1 plus 2, which is 3. And then now, how about this height? Because the input is 1, so I will have 1 plus 2x now. Okay? And of course, to this length right here, it will be x minus 1, right? Okay. Then now we go through the same process. So I have 3 plus 1 plus 2x multiplied to x minus 1 all over 2. Okay. And then I will have 4 plus 2x x minus 1 over 2. 4x minus 4 plus 2x squared minus 2x over 2. And now we will have this one, it will be 2x squared plus 2x minus 4 over 2. And of course, the answer will be x squared plus x minus 2 then. Ooh. So Now, you will see that what is this equal to? This is actually equal to a of x, right? It's kind of like the area depend on this input x right here. Okay. Okay. And now, if we let a of x equal to this one, so I know that this is actually is equal to x squared plus x minus 2. Then now, what if I want to take the derivative of this a right here? What do we have? We got 2x plus 1. This is 1 plus 2t or 2t plus 1. This is 2x plus 1. Well, it seems that if I take the derivative of this integral right here, what do we have? We just need to replace this variable with this input x right here. Then we are done. This is exactly what fundamental theorem is talking about. Okay, so let us look at the general case right here. If we take the integral of this function f of t, the lower limit is a constant a, and the upper limit is a variable. Then in this case, is actually we will be able to find the area between a and x, okay? And this is actually is the idea about this integral right here, okay? And remember this x right here and this x, they are the same variable. The reason is because this area right here is depend on the input x, right? Okay. And then you could consider that this t right here is kind of like a dummy variable in this case then, okay? It's just a variable of the integrations, okay? Okay, so therefore again, this example right here, the example that I just showed you, is that say that if we first integrate and then we take the differentiate, the result, we get back to the original functions. We get back the integrand. Okay, so therefore again, the Theorem 5.4, this is actually part 1, part 2 is actually section 5.3. Okay, fundamental theorems of calculus. If f is a continuous function on AB, just like this function right here, we have a function on AB. Then the area function of f with left endpoint A, remember A must be a constant, is a of x is equal to the integrate from a to x of f of t dt, where x is the number in between a and b. Is continuous on AB and differentiate on AB. The area function satisfies that a prime of x equal to f of x. Or equivalent, a of x is the derivative, okay, dx of the integral a to x of f of t dt equal to f of x, which means that the area function f is the antiderivative of f on AB. Okay. And also notice that a of a is satisfy this initial condition, right? If we want to integrate between a and a of f of t dt, it must be equal to 0 then, again, because there's no area. Okay, so then now let us look at the conceptual insight right here. By the FTC, the fundamental theorems of calculus, we start with continuous function f of x. And from the integral a to x of f of t dt, then you get back to the original functions by differentiating, okay? F of x, we integrate, and then we take the derivative, we get back to f of x. So this is actually is the idea. Okay, so let us use this, the following example, okay? work out this problem right here. Okay, so the graph of f is shown that in the figures. Okay, and then let a of x is equal to integrate between -2 to x of f of t dt, and capital F of x is integrate from 4 to x f of t dt. Okay, be the two area functions of f. So right now, what I would like to do is I would like to evaluate the following. Okay, A40. Okay, so let's see. If I want to evaluate a of -2, then in this case, it will be between -2 and -2 of f of t dt. Then of course, my answer is equal to 0 then, right? Okay. Then now, how about a of 4? Then here, I will have between -2 and 4, f of t dt. Then between -2 and 4, that means what? I will have 8 plus 17. So the answer will be 25. Then. And how about a of 8? Then I have this from -2 to 8 of f of t dt. Then, of course, to this one right here, then I will have 8 plus 17 minus 9 then, right? So, of course, in this case right here, I will have 16 now. Okay, then now, how about f of 8? And in this case, f is this function, so I will have it from 4 to 8, f of t dt. Okay, so from 4 to 8, then I will have -9. And of course, it's from 4 to 4, f of t dt, then I will have 0 then. Okay, so then now, I would like you to, again, pause the video. Now go ahead and work on number 2, okay, to see if you get the answer now. Okay. Okay, so then let us start with a of 1. So I will have from 0 to 1 of f of t dt. Okay. So 0 to 1 basically is this area right here. Okay. Then you will see that to this one, basically this is just a triangle, right? So I will have this essentially is equal to 1 times 1 over 2. So I have 1/2. Okay, then a of 2. So I have it between 0 and 2, f of t dt. Okay, so then a of 2 actually is this area right here. So I will have 2 times 2 over 2. Then I will have 2. Easy, huh? Okay, then now, how about a of 4? 0 to 4, f of t dt. So I have this is this area. Okay, so basically this one right here is kind of like we have 0 to 2 f of t dt plus this area right here. So it's a square, right? So I will have 2 times 2. Okay, then of course the result that I have, it will be 2 plus 4, then it is equal to 6 now. Okay. Then the last one, okay, is actually is a of 6. Okay, a of 6 meaning this whole thing. So I have from 0 to 6 f of t dt. Then it will be between 0 to 4 f of t dt plus the a quarter of a circle, right? So then this one right here, it will be pi 2 square over quarter 4. And of course, we know that these two cancel. So the answer that I have, it will be 6 plus pi then. Yeah. Okay, so now then let us continue. Okay. So to this one, I would like to have g of 1. Of course, we know that this is equal to 0 right away. And now we know that g of x is actually equal to integrate from 1 to x of t squared minus 2 dt. Then what is g prime of x? Okay. G prime of x meaning we take the derivative of the integral. Okay. And then, of course, we know that just based on the fundamental theorems right here, it is equal to f of x, right? Okay. So then, to this one right here, we get x squared minus 2 then. Okay. So this is what we know. Then now, we could actually try to find g prime of 1, basically is 1 squared minus 2. So it is negative 1. And g prime of 2, it will be 2 squared minus 2. 4 minus 2, which is 2 then. Okay, yeah. The next one is, looks like really odd, huh? Okay, so to this one, number 4, again, we would like to work with, let's find h of negative 2 and h prime of negative 2. So, and again, just like problem number 3, right? This one, okay. Then let's see, look at the answer that we have. H of negative 2, we integrate between negative 2 to negative 2, d of u and u squared plus 1. Of course, I know that the answer is equal to 0 right away. And then now, I would like to find h prime of x, which is d dx of negative 2 to x, du u squared plus 1. Okay. And then I know that this answer right here is equal to 1 over x squared plus 1. And now, my h prime of negative 2, it will be 1 over negative 2 to the square plus 1. So I will have 1 over 5 then. Okay, so I hope that just based on the two examples, number 3 and number 4, then you understand or you know exactly what is going on with these fundamental theorems of calculus. Okay. Okay, so and now let us look at these two examples, number 5 and number 6 now. Okay, so to this number 5, I would like to take the derivative of this one. So right away, I hope that you could write down the answer is 1 over 1 plus s squared. Okay, the tangent of 1 over 1 plus s squared. Okay, so number 6. I would like to evaluate the derivative of integral from a to x of f of t dx, dt, and the derivative, okay, d dx of a to b f of t dt. where a and b, they are constant. Okay, so then, now of course, the first one, we know that to this one right here, basically is d dx of a to x of f of t dt, which is equal to f of x, right? Okay, the idea is fundamental theorems of calculus. And then number two, if we take the derivative of a to b of f of t dt, remember b is actually a number. So basically we take the derivative of a number, right? A constant, okay? Now what does this mean to number two right here? If you look it back to our really first function example right here, then you will see that if I evaluate from 1 to 4 of a function dt, what happened? We get a constant. So if we take the derivative of a constant, of course, it is equal to 0, okay? So therefore, this one right here is equal to 0 then. Okay. And now, let us work with the next one is, what if this is not just a simple x, it's actually a function? Then how do we take care of it? Then we need to work with the fundamental theorems of calculus with the chain rule now. So when the upper limit of the integral is a function of x rather than x itself, we use some fundamental theorems of calculus together with a chain rule to differentiate the integral. So if I have g of x is equal to the integral a from a to g of x of f of t dt, then in this case, the derivative g prime of x, it will be f of g of x, g prime of x. Okay, just using the chain rule then. Okay, so then now I would like to find g prime of 1, where g of x is equal to integral from 0 to x squared of square root of t to the q plus 3 dt. Okay, so in this case, then what do I need to do first? I would like to take the derivative first. Then I will have g prime of x is d dx of 0 to x squared t to the q plus 3 dt is equal to f of g of x. Now again, this is here, and I will have this one, I replace t by x squared plus 3, and then I will take the derivative of x squared. Okay, chain rule. Then in this case, my g prime of x is equal to 2x times square root of x to the power of 6 plus 3. Okay. Then of course, my g prime of 1, it will be 2 times 1, square root of 1 to the power of 6 plus 3. So I will have 2 times 2, so my answer is 4 then. Okay, so now let us practice. Okay, how do we take the derivative now? Work with the fundamental theorems with the chain rule, right? Okay. So therefore, this one right here, it will be cosine cube of 1 over x. And then we take the derivative of 1 over x. Okay. And then, now, again, remember the derivative of 1 over x is x to the negative 1, right? So therefore, I will have negative 1 x to the negative 2, right? Or 1 over negative 1 over x squared then. So then I will have negative 1 over x squared times cosine cube of 1 over x. Okay, so, and now let's think about how do we actually take care of b here. Now remember, the fundamental theorems of calculus tell us that we have to start with a number, any number, okay? And then work with a function, right? However, in this case, then we don't have any number right here. Then how do we actually work it out? Okay, so then let us consider that this function now. Okay, so then to this function right here, we have square root of t. Okay, I have f of t then. Then in this case, we have this is the t-axis right here. What if I consider that here I have 1 and then x squared is before and then x to the power 4 is after 1. Okay, so 1 is in between x squared and x to the power 4. Then in this case, what I could do, I will be able to rewrite this into integrate, okay, from x squared to 1 of square root of t dt plus 1 to x to the power 4 square root of t dt then. Okay. Can we do this? Yeah, of course we could, right? Then now we could actually, let me modify this a little bit. So we could actually have this one is a negative of 1 to x squared square root of t dt plus 1 to x to the 4th square root of t dt. Okay. Yeah. And now we could actually do this now. Then we're going to have a negative square root of x squared and take the derivative with respect to x of x squared plus square root of x to the power 4, take the derivative of x to the power 4. Okay. Then I will have negative 2x times x plus x squared times 4x to the cube. Mm-hmm. Okay, so this is actually the last problem that we have to these sections. Okay, so again, let's try to pause the video and then, okay, take your time to finish this problem then. Okay, so to this one, I would like to find a of x is equal to the integral between 0 and x of f of t dt. Okay, just like this one. And then I would like to calculate a of 2, a of 3, a prime of 2, and a prime of 3. Okay. Okay, so maybe let us begin. First of all, I would like to evaluate a of 2. So meaning I would like to integrate between 0 and 2 of f of t dt So then you will see that in this case right here, I am actually I'm looking for just this, okay, between 2 and this is 2 right here. Okay, so therefore, of course, I know that this answer right here, it will be 4 then. Okay, then now, how about a of 3? I would like to integrate between 0 and 3 of f of t dt. Okay. Okay, so in this case right here, meaning I'm looking for this area. So therefore, to this one right here, I know that I would like to have between 0 and 2 of f of t dt plus between 2 to 3 of f of t dt then. Then of course I know that this is 4. And then to this one right here, I will have 2 plus 3 multiplied to 1 over 2 then, right? So then in this case, I will have, this is 4 plus 5 over 2, then it is 13 over 2. Okay. Or if you want to, just write down 6.5 then, right? Okay, then now, I would like to work with the prime now. So right now, I would like to find a prime of x. Then we know that this is a ddx of 0 to x f of t dt. Okay. Then in this case, we know that this is basically is equal to f of x. Okay. So therefore, in this case right here, so I will have a prime of 2 is equal to f of 2. Then in this case, we know that f of 2 is equal to 2. And how about a prime of 3? It means that is equal to f of 3. And then of course, f of 3 is equal to 3. Right? Mm-hmm. Yeah, good. Okay, so then this section is actually, we are done. Now remember in this section right here, we learn the fundamental theorems of calculus. Then this is actually is the idea right here. Okay. If we have a functions, we integrate the functions, and then we take the derivative. It will go back to the original function f. This is the idea right here. Okay. Okay, so thank you, and then see you next time.